Everyone, morning guys. Morning everyone. What was the last topic we were talking about? Okay, so we were talking about displacement. So guys, we are talking about rectilinear motion and in that, is it visible to everyone? Ishpandana, is it visible to you? Okay. So we are talking about displacement, and I told you that displacement is nothing but the final position vector minus initial position vector is nothing but displacement. Then we saw that it is delta R is equals to R2 minus R. Now guys, can I say that since displacement is a vector quantity, can I say that it may be positive, negative or zero? Is it right? Can I say that since vector displacement is the vector quantity, so everyone write down a point. Displacement can be positive, negative or zero. Everyone note it down. Since displacement is a vector quantity, it is nothing but the final position vector minus initial position vector. The change in the position vector of the particle is called displacement. So since it is vector quantity and vector quantities can be positive, negative, zero, so it can be positive, negative and zero. Now, the next we need to talk about distance. Can anyone tell me what is distance and how it is different from the displacement? Can anyone tell me what is the distance, how we can define the distance, and what is the difference between displacement and distance? Akshita, that's right. Correct. No, Syed, it is not the magnitude of change in position. Distance is actual path length traveled by particle in given time interval is called distance. So actual path length, displacement have direction, but distance doesn't have direction. That is also right. That can be a difference. Priyanka is saying that shortest distance is straight path from A to B. That is also right, Priyanka. That's good. Displacement traveled by a body. No, displacement is vector and distance is scalar. That's right. Good. So, guys, basic differences, you know that displacement is a vector quantity, distance is a scalar quantity. The main thing what we need to see, just look here. So this is distance, actual path length traveled by the particle in given time interval. Now let's suppose this is point A and this is point B. So a particle from A to B can go by this way, direct straight line, or if it wants to move like this. So can I say that if let's suppose if the particle is going to move by A to B by this path, let's suppose I am saying that this path is ACB. So can I say that if a particle is moving from ACB, can I say that this is nothing but distance, and whatever is going to be the length of AB, can I say that this will be nothing but displacement? So if you look, actually particle is moving by this path, ACB, that chord path, that zigzag path. So whatever is going to be the length of this ACB path, that will be distance. But if I talk about displacement, so displacement is nothing but the final minus initial along the straight line. So can I say that along a straight line, this will be displacement, while this zigzag path length is going to be distance? Is it clear? What is the difference? So whatever the actual path length this particle is going to travel, that is called distance, while the shortest path or the distance along a straight line joining those 2 points, that is going to be displacement. Is it right? So everyone note it down, then we'll try to solve some questions. Everyone first note it down. Everyone just note it down, then we'll try to solve some questions. Guys, once noted, just let me know. Is it done? Everyone noted down. Displacement, listen guys, displacement is nothing but the minimum distance along 2 points. So if you look along A and B, the minimum distance will be along a straight line. I told you that in between 2 points, the minimum distance is always along the straight line. So if you look A to B, the minimum distance is straight line, while the particle was moving by this path, A to B to B. So in this case, A to C to B, whatever is going to be the length of the path covered, that will be the distance. So everyone noted that. Clear to everyone? Shall we solve the questions? Right, distance displacement clear. Now, try to solve this question. Let's suppose this is semicircle. Radius of this circle they have given as radius is 2 meter. Radius is 2 meter. Here, one particle is moving from A to C. One particle is moving A to B to B, and another particle is moving A to C to B. Is it clear to everyone? If you look, one particle is going to move towards this chord path, semicircle path. Another particle is going to move towards this straight line. So now is it visible to everyone? Guys, is it visible now? Someone was saying that it was dim. Okay. So one particle is moving by the path A to B to B, and another is moving from path A to C to B. I'm assuming let's suppose this is particle P which is moving towards this, and this side particle Q. Particle Q is going to move along a straight line, particle P is going to move along this. Then find the displacement and distance of particle P and Q. Everyone try to find out. Q is moving along ACB, P is moving along ADB. So everyone try to calculate. Guys, everyone noted? Everyone calculated? Okay. So for point P, for particle P, if I talk about, so can I see that particle P is going to move on this path? So how much is distance? Can anyone tell me? How much is distance? Can I say that the length of this semicircle is nothing but pi r, because total circumference is 2 pi r. So can I say that semicircular path, the circumference will be pi r. So pi into r means r is 2 meters. So 2 pi. Displacement, can anyone tell me? Displacement. So displacement is nothing but the minimum distance between A and B. Whatever the path the particle has been traveled, when I'm going to talk about displacement, we don't bother about that. We just see the minimum distance along a straight line joining those 2 points. So if you look along these 2 points, if I'm going to join by a straight line, can I see that displacement will be 4 meters? Is it right? For point Q, if I talk about for particle Q. So can I say that for particle Q, it is moving along this straight line. So distance is nothing but distance travel. So 2 meter, 2 meter, total 4 meter. And displacement. So can I say that displacement, the particle is moving along a straight line and minimum distance is also the same thing. So it is going to be 4 meters. Is it clear to everyone? What is the basic difference between distance and displacement? So distance, the actual path length, while displacement is nothing but the minimum distance between those 2 points. So guys, by looking at this, can I say that distance will be always greater than or equals to displacement? If you look, can I say that the displacement will be always greater than or equals to distance traveled is always greater than or equals to displacement? Because if it is moving along a straight line, if it is moving along a straight line, then displacement and distance will be equal. But if it is moving along curved path, definitely it is going to travel more distance. It is not possible that distance is going to be more than displacement. Displacement is going to be more than distance. I didn't get that partial P, so then it is not partial, it is particle. Look here. Particle P is moving along this path. Particle P is moving along this path. So what is going to be the length of this path? Can I say that pi into r, because this is a semicircle radius they have given 2 meters. So for a circle, total is 2 pi r. So can I say that half is nothing but pi r? So pi into r is 2 meters. So 2 pi is nothing but the distance traveled, and displacement is nothing but the minimum distance between point A and B. So it is along a straight line, and actually this is nothing but a diameter. So diameter is going to be 2 plus 2, 4 meters. Now is it fine? Is it clear? And in the same way, for particle Q, since it is moving along a straight line, so whatever is going to be displacement and distance, both are going to be same. So by looking at this, or this question and solution, we can easily see that distance traveled is always greater than or equals to displacement, because displacement is minimum distance. If you are going to choose any other path, definitely it is going to be more than the displacement. It is not possible that distance traveled is less than the displacement. So after this, everyone note it down. Guys, have you noted down, everyone? So we can write down one statement that distance is always greater than or equals to displacement. Can I say that distance traveled by a particle will be always greater than or equals to displacement of the particle? Is it right? Can we say that? Is it clear to everyone? Okay, so everyone note it down. Next, average velocity. Average velocity. Can anyone tell me what is average velocity? How we can decide, how we can define average velocity? total displacement by total time, right? So it is nothing but it is ratio of total displacement it is the ratio of total displacement to total time taken by particle. It is the ratio of total displacement, whatever is going to be the displacement, to the total time taken by the particle. How much time it took for that displacement? That is nothing but the average velocity. So can I say that average velocity if I talk about? Total displacement, can I say that delta x divided by delta t? Is it right? Delta x is nothing but change in displacement, change in position divided by change in time. Delta x is, or first we can write down total displacement divided by total time taken. Now, total displacement means change in position, that is nothing but the total displacement. So, delta x divided by delta t. Delta x, can I see that final position vector minus initial position vector divided by total time taken. This is going to be the average velocity. Is it right? Everyone clear about this? So, it is defined as total displacement over total time taken. Everyone just note it down. Delta x is nothing but change in position vector. Delta t is change time interval. You can write down here. Delta x is change in position vector. Delta t is nothing but time interval. Delta t is time interval. So everyone note it down this formula. Guys, once noted, just let me know. Done. Will distance can be zero? Definitely, Rutvik. The distance can be zero. The distance can be zero. In that case, displacement is also going to be zero. If particle is not going to move, if it is going to be at rest, the distance traveled in any time interval, it is going to be zero. Guys, after this, write down a statement. Average velocity is a vector. Distance can't be negative. That's right. Distance can't be negative. It is a scalar quantity. Distance can't be negative. Guys, write down. Average velocity is a vector quantity. Average velocity is a vector quantity in the direction of displacement. Average velocity is a Average velocity is a vector quantity in the direction of displacement. Average velocity is a vector quantity in the direction of displacement. Everyone know this? Is it done? Everyone note it down? Okay. Now let's suppose the next is instantaneous velocity. Next one is instantaneous velocity. Okay, guys, someone wants to repeat me. Write down. Average velocity is a vector in the direction of displacement. Average velocity is a vector. Average velocity is a vector in the direction of displacement. Now let's suppose, guys, let me take an example. I'm talking about instantaneous velocity. Let's suppose if you are driving a bike, and if I ask at any moment that what is the speed of the bike, what you are going to tell me? So can I say that you are going to look in your speedometer, whatever is the velocity, you are going to tell me the same thing. If the needle is going to be at 40, you will tell me that it is right now 40 meter per second. Is it right? Or if it is 60, then you will tell me 60 meter per second. Is it right? Now, let's suppose after 2-3 minutes, I once again ask. So can I say that now it can be changed from 60 to 40 or 50 or something like that? So guys, what does it mean? It means that can I say that instantaneous velocity is actually the velocity at that particular instant, whatever the velocity of the particle is going to be there, that is nothing but instantaneous velocity. Is it right? Is it right? Means, can I say that now mathematical term, just listen, can I say that it means that we are talking about a very small instant. A moment means, can I say that a very small interval of time, that is nothing but a moment. How we can define a moment? So can I say that it is going to be a very, very, very small, means dt. Akshita, that's right. Can I say that it is nothing but dt time interval? Dt time interval is very small. If you look, it is nothing but 0.00 so many times and 1. So can I say that? That's why we talk about the differentiation, because here we are going to use that for a small time interval. We know that it is nothing but dt, small dt, that is going to be small time interval, and actually that is nothing but a moment. A moment means one instant of the time. So now next we need to talk about instantaneous velocity. Next is instantaneous velocity. It is going to be at any instant. At any instant. So write down the definition of the instantaneous velocity. The velocity at particular instance, write down the definition. The velocity at particular instant of time. The velocity at particular instant of time. The velocity at particular instant of time is known as instantaneous velocity. The velocity at particular instant of time. The velocity at particular instant of time is known as instantaneous velocity. Full stop. It is the velocity at any moment. It is velocity at any moment of time. It is velocity at any moment of time. Everyone noted? It is velocity at any moment of time. Now, how we are going to define it? So, instantaneous velocity. Instantaneous velocity. So, if you look, average velocity, what I shown you, that is nothing but delta x by delta t. Delta x by delta t, that was nothing but the average velocity, total displacement by total time. Now, let's suppose if I want to represent that this time interval is going to be very small. So for that one, we use the representation limit. Limit delta t tends to 0 shows or represent, limit delta t tends to 0 represent that time interval is going to be nearby 0. So can I say that if time interval is going to be nearby 0 means very small, can I say that it is going to become a moment or instant? Is it clear that if time interval is going to be nearby 0, it becomes a moment or instant? So can I say that if time interval is very small, the particle is going to travel a very small distance? Is it right? Can I say that at a moment? Can I say that in that moment the particle will just travel a very small distance? So can I say that limit delta t tends to 0? Can I say that it becomes nothing but this displacement will be very small, very small. This time interval will be very small, and representation of very small quantities nothing but dx and dt. Is it right? So can I say that at any instant, whatever is going to be the differentiation of the position of the particle, actually that is nothing but instantaneous velocity. Is it right? So this is nothing but formula for instantaneous velocity, that is dx by dt. This is displacement. Since I am talking about velocity, guys, okay. Velocity, don't get confused. It is very simple to identify, to differentiate. If I am talking about velocity, velocity is a vector quantity, then this will be displacement. After some time, I'm going to talk about average speed and instantaneous speed. So speed is a scalar quantity. In that case, we will take the distance. So is it clear? When it will be displacement, when it will be distance. So if I'm talking about velocity, which is vector quantity, I will take the displacement, because displacement is a vector quantity. This will be vector, this will be vector, because time interval is not a vector quantity. Clear? Okay. So everyone noted down the formula. Once noted, just let me know. Can we write it as ds by dt? Why time tends to 0? Sir, because I want, if I'm saying that any moment or any instant, so can I say that moment of time is a very small quantity, very small time interval, and that's why I'm making it approximately 0. Nearby 0 means very small, because we are talking about an instant or a moment. The moment is very small time interval. Did you get it? Delta x to dx. Ayan Khan, look here. If I say that in 0.00001 lakh times 1, how much distance you can travel? So can I say that you are going to travel a very small distance because time interval is very small? How much you can travel? Very small distance. That's why I have changed it to dx. Clear? Delta becomes dx because time interval is very small. This delta x was when delta t was bigger. When time interval was bigger, the displacement was bigger. Now the time interval becomes very small. Can I say the displacement is also going to be very small? Okay, write down a note. Write down a note. Write down a note, guys. First one. Instantaneous velocity. Instantaneous velocity. Instantaneous velocity in bracket magnitude. I am talking about only magnitude. So write down instantaneous velocity in bracket magnitude and instantaneous speed. Instantaneous velocity in bracket only magnitude I am talking about. So in bracket magnitude. So instantaneous velocity in bracket magnitude and instantaneous speed is same. Instantaneous velocity in bracket magnitude, instantaneous velocity in bracket magnitude and instantaneous speed is equal or same, both are the same thing. Instantaneous velocity in bracket magnitude and instantaneous speed is equal. Everyone noted? Because when we are talking about magnitude of the velocity at any instant, can I say that it is nothing but a scalar quantity? And the speed at that moment, that will be also the same thing. So magnitude of the velocity is always going to be equal to the instantaneous speed. Is it clear? Now listen one more thing. Now they can give you, listen here. Listen here. Now they can give you the displacement. You are able to calculate. So if they have given the displacement, you will calculate the instantaneous velocity. But in question, they can ask the speed. So actually, they are asking the magnitude of the velocity, and which is going to be always equal to the instantaneous speed. So if they have given the displacement, and if you are able to calculate the instantaneous velocity, magnitude of that velocity is always going to be speed. Is it clear? Is it clear? What is the instantaneous velocity? How we have defined? Okay. Write down one more thing. Write down one more note. Guys, write down one more note. The second one. Instantaneous velocity is always tangential to the path. Instantaneous. First one, guys. Someone asking first one. First one was instantaneous velocity in bracket magnitude. Instantaneous velocity in bracket magnitude and instantaneous speed is equal. Instantaneous velocity in bracket magnitude and instantaneous speed is equal. Second note, instantaneous velocity is always tangential to the path. Instantaneous velocity is always tangential to the path. Instantaneous velocity is always tangential to the path. Everyone noted? Okay. Now the next is average speed. Now, if I talk about average speed, till now we were talking about velocities, which are vector quantity. Now we are talking about speed. Can anyone tell me how we can define the average speed, guys? Just let me know. So it is nothing but total path length traveled divided by total time, or total distance traveled by total time. Good. So average speed. So average speed is going to be always in a time interval. So how we can define magnitude of the changing position? No, Sayyid, that is going to be wrong, because magnitude of change in position is nothing but the magnitude of displacement. Here we are talking about the distance. So if I talk about average speed, so can I say that average speed can be defined as, can I say that, guys, it is nothing but the total distance traveled by particle divided by total time taken. Is it right? Can I say that? In this one, it will be total distance traveled or total path length covered by the particle. So everyone write down the definition. Everyone write down the definition of average speed. Average speed is defined as, average speed is defined as, average speed is defined as total path length traveled. Average speed is defined as total path length traveled divided by the total time interval, divided by the total time interval, divided by the total time interval, during which, total time interval during which motion has taken place, during which motion has taken place. Have you noted? Guys, have you noted down? Okay, right on. Average speed is defined, guys. In one way, in one time, try to listen and write it down. Average speed is defined as the total path length traveled. Average speed is defined as the total path length traveled divided by the total time interval, divided by the total time interval during which the motion, total time interval during which the motion has taken place. The motion has taken place. So can I say that average speed is nothing but total distance travel divided by total time taken. Now, can anyone tell me what is going to be the unit of average speed and what is going to be the dimension? Can anyone tell me what is unit and dimension of this? So look here, what will be the unit of average speed? So it is nothing but meter per second. The distance unit is meter and time unit is second. Now meter is nothing but length. So meter is nothing but length. Length is going to measured in meter and second is nothing but time. So length divided by time t. So it is going to be LT minus 1. What is the second note? Second note was that magnitude of instantaneous velocity and speed is always equal. You need to remember that magnitude of instantaneous speed and instantaneous velocity magnitude will be always equal, because at the same instant, if I'm not considering the direction, whatever will be the instantaneous velocity magnitude, it is going to be always equal. That is simple. Is it clear? That unit is meter per second, and how I calculated dimension. So meter is nothing but length divided by second is time. So L divided by T can be written as LT minus 1. So this is the dimension. Now in this one, also write down few notes. Everyone noted on this formula? So most important is this formula. We always need to remember this formula. You are going to use this formula frequently, that average speed is total distance traveled by total time taken. Velocity, guys, if you have not written, you can write down the unit of average velocity and instantaneous velocity is also the same thing, meter per second. You can write down there unit of average speed, average velocity and instantaneous velocity. If you have not written, just note it down there. Unit of average is velocity and instantaneous velocity is also meter per second, because whether it is displacement or distance, the unit is going to be meter. Clear to everyone? What is the unit of average velocity and instantaneous velocity? Is it clear, guys? So it will be meter per second. Satvik, just wait. When I'm going to solve few questions, I will tell you that what is dx by dt and why it is tangential. Just wait for a few minutes. When we are going to see the definitions, after that, when we are going to calculate, when we are going to solve the question, we'll see that what is the meaning of that tangential. So just wait for a few minutes, then we'll see that. Guys, everyone noted down this formula. So we are going to use this formula frequently. Everyone write down the first note. Everyone write down the first note. Average speed is always positive. Average speed is always positive. Average speed is always positive. In contrast to average velocity, average speed is always positive. Average speed is always positive. In contrast to average velocity. In contrast to average velocity, which being a vector, which being a vector, which being a vector can be positive or negative. Which being a vector can be positive or negative. Which being a vector can be positive and negative. Everyone noted? Write on the second note. Write on the second one. Write on the second. If the motion of the particle is along a straight line, if the motion of a particle, second one, write on. If the motion of the particle is along a straight line, if the motion of a particle is along a straight line in the same direction, in the same direction, in the same direction, then average speed is equals to average velocity. Then average speed is equals to average velocity. Then average speed is equals to average velocity. Everyone noted? Write down the third note. Write down the third one. Average speed is in general. Average speed is in general. Average speed is in general greater than the magnitude of average velocity. Average speed is in general greater than the magnitude of average velocity. Is greater than the magnitude of average velocity. Everyone noted the all 3 points? Guys, have you noted down, everyone? Okay. So let me explain these points, what we want to say. First one is saying that average speed is always positive. So it is very simple. If you look, average speed. So in average speed, it will be distance traveled, time taken. So time interval is always going to be positive. Time interval will be always positive. Total distance traveled. So total distance traveled is always going to be positive. So a particle is moving, distance traveled will be always positive. While in average velocity, this is displacement, and since displacement is a vector quantity, can be negative. So can I say that average speed will be always positive, but average velocity can be positive or negative because it is a vector quantity and vector can be negative. First point clear to everyone? First point, guys, clear to everyone that average speed is always positive because it is total distance traveled, and distance traveled is going to be always positive because it is a scalar quantity. While average velocity, since it is a vector quantity, it can be negative or positive. Clear? First one. Second point, they are saying that if a particle is moving along a straight line in same direction. So can I say that, guys? Let's suppose if a particle is moving from A to B like this. So can I say that distance and displacement both are equal, because this is nothing but along a straight line, distance will be same, displacement will be same. So can I say that if distance and displacement is going to be same, if I talk about the magnitude of average velocity, so it is nothing but magnitude of displacement, which is equals to distance. So can I say that magnitude of average velocity and average speed both are going to be same? Because in that case, displacement and distance both are going to be equal. And third, they are saying that in general, the average speed is going to be more as compared to average velocity. Why? Because average speed is distance traveled, and distance travel in general, it is going to be greater than or equals to the displacement, and because of that, average speed will be always greater than the average velocity. Is it clear now? All the three notes clear to everyone? Guys, is it clear? Okay. All right. So everyone is start writing few questions. First one is saying that average speed is always positive. Why? Because distance traveled is a scalar quantity, it will be always positive. Time taken, so time interval will be always positive. So this is going to be a positive. While in average speed, this will be displacement. So can I say that displacement can be negative? So negative divided by positive, it will be negative. Clear? Yeah, Sanjay, these all are in the material. They have already given. We need to explain, we need to understand, and then we need to solve the question. We have to see how we can apply them. Is it clear to everyone? Third point, if you look, I told you that distance is always going to be greater than r equals to displacement. So can I say that since distance is greater, the average speed will be always greater than r equals to the average velocity. So in general, it is going to be always greater because only in one situation, average speed and magnitude of average velocity is same when both are moved, when the particle is moving along a straight line in the same direction. Is it clear? That's why they are saying that in general, it is going to be greater. Clear? Okay, guys. So everyone try to solve some questions on this. Whatever the formulas, whatever the definitions we understand, we learn. We need to solve some questions. Everyone write on the first question. When displacement is negative. Look here, few people are having when displacement is negative. So me, let's suppose I have assumed this direction as positive, this direction as negative. This is point A, this is point B. Distance in between them is 3 meters. So can I see that when particle is going to move from A to B, can I say that it is moving in positive direction? While when it moves from B to A, can I say that it is moving in negative direction? So here it is negative -3, here it is +3. Clear? So when it is going to move in opposite direction, it will be negative. So is it clear? Okay. Now everyone write down some questions on this. Everyone write down the first question. Let's suppose whatever the question I have given you, the same thing I am talking here. Let's suppose this is point A, C, B, A, C, B, and this is point A, D, B. Particle P is moving along this path ADB. Particle Q is moving along this path ACB. So we need to find first average speed of particle P and Q, and second part average velocity of particle P and Q. What they have given that Q is moving along ACB and it is going to take 4 seconds. It is taking time interval 4 seconds. And this P is going to take the time interval. Let's suppose it is taking the time interval delta T, that is nothing but 10 seconds. Is it clear? Question clear to everyone? P is moving along this semicircular path, taking the time interval 10 seconds. Q is moving along this ACB path, taking the time interval 4 seconds. So we need to find out average speed of particle P and Q and velocity, average velocity of P and Q. Everyone try to find out and let me know that. Radius of the circle, last time I have taken it is radius is 2 meter. The same question, radius is 2 meter. Last time I have given it is 2 meter. So everyone try to calculate and let me know what is the answer. Guys, have you calculated? Did you get the answer? Guys, anyone who get any answer? Okay, so most of the people get the answer. How does okay? How we are going to find out? So first one they are talking about average speed. So I'm talking about for point P, for particle P. Average speed. What was the formula I told you? That is total distance divided by total time, right? For particle P. So particle P is moving along this path. Total distance traveled is nothing but pi r, means 2 pi, and time taken is nothing but 10 seconds, means pi by 5 meter per second. This is the answer. And for particle Q, the average speed. So again, total distance. So Q is going to travel on this straight line. The distance traveled is 2 meter and 2 meter. 4 meter divided by time is 4. So 1 meter per second. This is the average speed of particle Q and particle P. Is it right? First part clear to everyone. The average speed of particle P and particle Q is this much. Is it clear? Now, the second one, if I talk about average velocity. In the second part, they are asking for average velocity. So, average velocity of for particle P and talking about. So, average velocity. So, it is nothing but displacement divided by time. Whatever is the displacement. Guys, can anyone tell me what is the displacement of this particle P which is moving around this circular path? What will be the displacement? So it is nothing but minimum distance, that is 4 meters. Good. So 4 meter. How much time it is going to take divided by how much time? 10 seconds, because it is taking 10 seconds. P is taking 10 seconds. So 4 by 10 meter per second. And for particle Q, can I say that average velocity? So particle Q, the average displacement is nothing but 4 meter, because it is moving along a straight line, and 4 seconds. So it is 1 meter per second. Is it clear? So this is going to be the average velocity of Q. This is the average velocity of P. Is it clear to everyone? So when we are talking about the velocity, I am taking the displacement of the particle. While I am calculating the speed, I am taking the distance traveled by the particle. Clear to everyone? Is this question clear? Okay, so everyone note it down. Then we'll try to solve the next problem. Everyone first note it down. Everyone note it down fast so that we can solve the second problem. Guys, once noted, just let me know. Everyone once noted, then just let me know. Have you done, everyone? Done. Okay, write down the next problem. Everyone, listen the next problem carefully and try to solve it right now. A particle travels. Write down the second problem. A particle travels half of total distance with a particle travels half of total distance with speed v1. Half of total distance with speed v1. Half of total distance with speed v1, and next half with speed v2, and next half with speed v2. A particle travels half of total distance with speed v1 and next half with speed v2 along a straight line. Along a straight line. Along a straight line. Then find out the average speed of the particle. Then find out the average speed of the particle. Then find out the average speed of the particle. Everyone try to find out. The question, guys, one time try to listen the question carefully. Every time, in every line, everyone is saying that repeat again and again. This is wasting our time. If I'm going to repeat whatever I'm going to teach you 1.5 hours, I will be teaching in 3 hours, because again and again I'm repeating it. So try to listen in one time and try to write it down fast. A particle travels half of the total distance. A particle travels half of the total distance with speed v1, and next half with speed v2, and next half with speed v2 along a straight line. Along a straight line. Then find out the average speed of the particle. Then find out the average speed of the particle. Then find out the average speed of the particle. Everyone try to find out. Then find out the average speed of the particle. Everyone try to calculate and let me know. And guys, your homework is mathematical tools. Exercise 1, 2, 3. Whatever is the remaining part, complete it. Tomorrow we will discuss mathematical tools exercise 1, whatever the parts were incomplete. So this is your homework, you can note it down. You need to complete exercise 1, 2, 3 of mathematical tools. So most of the people get the answer. The answer is 2v1 v2 divided by v1 plus v2. That's right, good. So most of the people get it. 2v1 v2 divided by v1 plus v2. How we are going to find out? The question is very simple. Just okay. They are saying that particle is moving along a straight line. So first draw a straight line. Particle, let's suppose moving from here to here. I am assuming that let's suppose the distance in between these 2 points. I'm assuming that let's suppose distance in between A and B is S. So they are saying that half of the distance it is moving with velocity v1. So half of the distance means, can I say that this is S by 2 and this is S by 2? Because the distance I have assumed total distance S. So S by 2, S by 2. S by 2 it is moving with speed v1 and this S by 2 it is moving with speed v2. So I need to find out average speed. The formula of average speed is nothing but total distance divided by total time. Now total distance, how much this point is traveling? So A to B it is traveling S. But time they have not given that how much time it is taking, but they have given that this much distance it is traveling with this speed. So can I say that, let's suppose in this one it is taking time t1 and in this half it is taking time t2. So we know that time is nothing but distance divided by speed. Distance divided by speed is time. So here S by 2 and speed is v1. And T2 if I try to calculate, so T2 is going to be distance, how much it traveled, S by 2 and speed is v2. So total time, if you look how much it is going to take from A to B, it is nothing but T1. In half this T1 it is taking, in this half it is T2. So can I say that it is T1 plus T2? If I put the values I have calculated, so S divided by S by 2v1 plus S by 2v2. So from here, if you look, it is going to be, if I take S common, so S divided by S by 2 if I am taking common, so it is 1 by v1 plus 1 by v2. This S got cancelled out, this 2 is going to be upside. So 2 and v1 v2 divided by, this will be nothing but v1 plus v2. So is it clear? Whatever the information they have given, according to that, I draw the diagram that particle is moving from A to B. Let's suppose the distance is S. Then half of the distance will be S by 2. Half of the distance will be S by 2. It is moving with velocity v1. Here it is moving with velocity v2. Now if I look in the formula, I need total time. Total time they have not given. Then we will try to find out by whatever the information we are having. So distance divided by velocity is nothing but time interval t1. In this half, distance divided by velocity will be t2. So I can easily put it down here and we can get the answer. Is it clear the question? What is the average speed? Is it clear to everyone the solution? Okay. So everyone note it down. After this, we will try to see the next. We will try to solve few more questions on this, and then we'll see the next topic. So this is your homework, guys. Try to complete. Tomorrow onwards, we will start discussion mathematical tools, and we will see the next topic of this chapter in the next class. Thank you, everyone. Everyone, just note it down. Is it done? Once noted, just let me know. Done, guys? Okay, so see you in the next class. Thank you, everyone. Thank you, guys.